All right, so today is a day 2 lesson of solving radical equations and inequalities. So our essential question is, how do I solve inequalities and rational exponent equations?
Yes. So last lesson, we were solving radical equations. And if you recall, what we were doing is we were raising both sides to whatever the index was so that we could cancel a radical.
Right.
Same thing's going to happen when you're solving rational exponents. Instead, though, you raise both sides of the equation to the reciprocal of the exponent.
Okay.
So we'll
So
go.
for example, if it was 1/4, you would raise it to the 4th.
Yes.
Okay.
And remember, to find a power of a power, multiply the exponents. So that's just a reminder.
Right.
So let's go. Let's
right.
do it, Miss Boyd. And I'm going to tell you this, the same holds, Miss Boyd. We still want to isolate if there is something next to the rational exponent, and there isn't right now. Mm-hmm.
So since it's by itself with the raised power, we're going to raise this up. Hey,
yes.
I picked
I'll be right back.
Okay. I raise this up. Oh boy.
I'm back.
What is going on
What
with this?
is it just not aligned?
I don't know.
Whoa. You gotta be kidding me.
Why does it not like me today?
It doesn't like her today.
What is going on?
Seriously, it's not working?
Oh,
there we
it
go.
worked.
Okay.
Okay, so we're gonna raise it to the 3rd.
They're good. They can figure it out.
So then that's gonna cancel.
Right, because you multiply 1/3 times 3 is 1. Right. So now we end up with 5x plus 7
equals 3 to the 3rd. So that's 3 times 3 times 3. So 27?
Yes.
Great. Now we just solve. So subtract 7 from both sides.
Right.
We have 5x
equals 20. Divide both sides by
5. X equals 4.
Correct. One thing I want to mention, Ms. Boyd, that's good, that's the answer, is again, just like yesterday, when we're raising something to an even power, we have to check for extraneous solutions.
Okay.
The odd powers, we don't have to check.
Great.
All right, let's go. Example 2. I say that, what do you think? Oh, we should do this because this isn't even. Yep.
All right, so it's by itself, so we're going to just raise it to the 2nd power.
Now it likes you.
It does. Must have just been.
And again, we didn't have to isolate anything.
No.
So
those cancel.
Yes.
So we're left with the 4x plus 8 on this side equals, now remember this 2
it's
goes
just
to
2x
both.
squared, right, Miss Boyd?
Right.
Just 2x squared.
No. This squared has to go to both. So 2 squared is 4.
Right.
And then x squared.
But I did that on purpose because students want to say it's 2x squared.
No.
No.
All right, now we got to move everything to the left because we want to get it equal to 0.
Yep.
So I'm going to subtract 4x.
And that's because there's an x squared.
Right.
That's the only reason.
So 4x squared
minus
4x equals 8. Subtract 8. Subtract 8. So I get 4x squared minus 4x minus 8 equals 0.
I'm going to scroll down for a minute. Now, some of you now are panicking.
No, don't panic.
Because you see
I know,
the
I started to.
is greater than 1. Oh, yuck. It's the icky factoring.
But no, we can take a 4 out of everything.
Because what's the question we always ask? Is there a GCF?
Yes.
And it's 4.
Sweet.
So now look what we have, Miss Boyd. We have an equation. So let's get rid of that 4.
Yeah, let's divide it.
Yeah, we can do that.
Divide both sides by 4.
And you want to?
Yep, I'll move it up.
Okay.
So those cancel. So we're going to go up here now. All right, so now we're left with x squared minus x minus 2 equals 0.
Do you guys notice Miss Boyd's little noises she makes when she does her arrow? She does.
Sure do.
I know, I just wanted to mention that. I love her little extra little noises she makes.
So now let's factor this. Are there any numbers that multiply together to give us -2 but add to give us -1?
-2.
2 and a 1. And then, yep, like you said, we need a -2 and a positive 1.
Yay!
Great. So now we set those
equals
both equal.
Equals
oh,
zero.
sorry.
Don't
Equals 0.
mess with me.
All right. Now we got to set them both equal to 0. So we get x equals 2.
Yep.
And then x plus 1 equals 0. So we get x equals -1. But
yes.
now we need to check these.
Yep. And
So
where do you think we want to
possible.
check it, Miss Boyd?
In the 4x plus 8?
Yep, the original problem. So I'm going to
Right.
scroll up. So what I was going to say is Not after they raise it to a power of 2. They want to plug it back into the original.
Original.
So let's plug in
Yep.
2 first on
So
both
I plug
sides.
in 2.
Yep,
I get 8 plus 8.
is 64.
6
Oh my gosh! I am so
16
sorry. Is
to
16,
the 1/2.
which means the square root of 16,
Right,
which is 4.
Which is 4. So that one works.
Yep.
All right, let's plug in negative.
But hey,
Oh.
hey, you got to plug, does that, yeah, it works, but guess what? You got to say, does it equal, if you plug a 2 in there, 2 times 2 is 4. 4
Right,
equals 4.
right.
Remember the
Oh,
last
sorry,
problem?
I
It did,
just-
yeah.
Sorry. I guess I did that in my head.
Oh,
Okay,
Miss
sorry.
Boyd is smarter than me.
No, never. All right, so now let's plug in the -1. We got -4 plus 8 is a 4.
The square root of 4 is 2.
And
So
if we
right now,
plug in-
we say, oh, yay, it works. But guess
Well,
what? Go to the other
That's
side.
a 2, and if we plug in -1, we get -2. Those don't equal each other.
Right, so therefore,
So this
-1
cannot
is
be an answer.
extraneous. The only solution is 2. I'm really happy we did that one.
Great.
So what we're going to do now is we're going to skip this one, and we're going to go on to this one. However, yeah, you know what? We actually probably should do this one because there is something to isolate.
Well, we just quick get rid of that
Yeah.
3.
So it's not hard or
So
anything.
once you get rid of the 3, x plus 6 to the 1/2
Equals 3.
equals 3. Now it's the same as
Raise
before.
both sides to a power of 2.
Square it. Square it.
Yep.
Those cancel. We're left with x plus 6 equals 9 minus 6
Yep.
minus 6, x equals 3.
And we have to check it.
Yep. So if we plug the 3 in, we get 9. Square root of 9 is
3.
3.
3 times 3 is 9.
We're
Done.
good.
Perfect.
Okay.
Easy. Okay, now we're done with those rational exponents. If you have a radical inequality, it's an inequality that contains a variable within a radical. And instead of an equal sign, you're using an inequality.
Okay.
We're going to solve them algebraically. And remember, a radical expression with an even index, 2, 4, 6, 8, and a negative radicand, that means the number under the radical, has no real roots.
Okay. So even index and negative radicand.
Yep.
No roots. Okay.
Here we go. Let's try it. So again, you always start by isolating.
Great.
You want your inequality isolated.
All right, minus
This
3.
board is
minus 3.
messing with us.
All right, so we got the square root of 2x minus 6, but I gotta make sure that 6 is
Oh,
under there.
yes, you
Otherwise,
do.
Missy, I will go crazy.
And I'm going to warn Miss Boyd of something right now.
Mhm.
Because there is an inequality, just like before we had the step, case 1, case 2, step 1, step 2,
Mhm.
similar, but there's just going to be a step 1
Right.
and a step 2.
Yes.
Right now, Miss Boyd's doing
Doing
step
step
1.
I'll just kind of write that. Step 1.
Mhm.
All right, so now we're
Raise
gonna
both
square
sides
both
to a power
sides.
2 because we know it's a square root because there isn't a 2.
Right.
There isn't an index listed.
So those go.
Yep.
We're left with 2x minus 6
Less
less
than
than
or
or
equal
equal to
36.
36.
Add
Add
6 to
6.
both sides.
We get 2x is less than or equal to 42.
Yep.
And divide by 2. X is less than or equal to 21.
Perfect. So
That's
she's going to
one
circle that.
answer.
That's step 1. I'm going to scroll down because I just don't
I'm
know.
going to do step 2 on the side here.
Are you
Yep.
You
'cause
sure?
Then I'm going to do
Oh,
my
okay.
line down
Okay.
there.
Sorry. All right.
Is that all right?
Oh my gosh. Yeah.
Okay.
Now, step
So
2. What we're going to state is that what's under the radical has to be greater than or equal to 0.
So 2x minus 6 has to be greater than or equal to 0.
Remember in the 8 whatever 5, I don't remember what section it was, but anyway, it had to be greater than or less than 0. That was different because that was in the denominator.
Right.
Now, this has to be greater than or equal to because you can't have a negative under the radical.
Right.
All right, go ahead.
So add 6.
Yep.
So we get 2x is greater than or equal to 6. Divide by 2. Divide by 2. X is greater than or equal to 3.
Yes. Now I'm going to scroll down for
Yes,
her
thank you.
because now what we have to do is we have to graph that because we have to see, is it an and, is it an or, what is it?
Making my sounds again. You're making me
I know.
self-conscious of those.
I
All
love
right,
her
So I got a
sounds.
21 and I've got a 3.
Yes.
So the red is x is less than or equal to 21. So that's a solid.
To the left.
And less than or equal to.
Yep.
And then the
3
one in
is
blue
blue,
is 3
solid.
is greater than or equal to 3.
Mm-hmm.
So if you see, we overlap here, so it's an
It's an and.
problem.
So we can write this two ways, Miss Boyd, and Miss Boyd. Okay, that's one way.
Okay.
Another way is you're gonna write the 3 down below, and then less than or equal to x less than or equal to 21. That's two ways. You can write it this way, what she just circled, or you can put an and in between the two answers, and that is acceptable too. Whatever you prefer. Just be very,
because I always forget.
yeah, and that's fine. But be very careful when you're graphing, because notice the 3 is on the left, the 21's on the right, Miss Boyd. Students, you know what they want to do? They want to go right there and put a closed circle on the 3 and go to the left. So be sure what you're graphing is the number you're supposed to be graphing.
Okay.
This looks real similar, so I think we're just gonna skip it.
Get it all the way,
Yeah.
and you're good.
And, let's do example 7, because it's different, because it's a cubed root.
All right, there's nothing to move, so we're gonna cube both sides. So that cancels. So we're left with x plus 2 greater than or equal to 1.
Now, there's good news here, Miss
1
Boyd.
times 1 times 1 is just 1. What's
There's
that?
good news. Because we're raising to an
an
odd
odd.
power, we
don't
don't
have to check
need
it.
a step 1 and a step
Oh, right,
2.
yeah.
We don't have to state x plus the square root of this. Oh, you know, I needed to show you something. I just thought, can I go back?
Yeah,
I'm really
sure, let's go
sorry.
back.
No, we're good. Oh, good. I wanted to make sure we didn't
I
do
wrote it.
Oh,
I'm
okay.
good.
I should know. She knows more than me. She hasn't.
No.
What I wanted to say is, well, I'm sorry, you do not have to state that x plus 2 is greater than or equal to 0, because it doesn't have to be.
Right. Just one case.
Yeah, so these are really easy.
All right. So yeah, subtract 2. We get x is greater than or equal to -1.
And you're done. See how easy
Bam.
that is?
You don't even have to check it because it's an odd power.
No, no. And you're not checking these inequalities. Your check on the even powers was your step 2.
Right, right.
That's your
Yeah,
checking.
that's right.
Okay?
Great.
I think we're done.
Wonderful.
That's it. Solve the equation.
Now remember on these, well, both of them, you got to get rid of this 4 first
Yep.
before you raise powers.
Isolate.
Okay.
I'm going to scroll down just in case, but I don't think we're covering any
Nope, we're
pictures.
good.
And we will see you tomorrow.
Bye.